Let's take a look at our type 2 logarithmic equations. So we're going to call this example 3. And so what we have is we have log base 72, and the result is a negative 2a plus 9 is equal to another log base 72 of 7 minus 4a. So you're going to notice that there's no simplifying needed. I have two separate logarithms, and there's nothing be attached to anything. I don't have to use any rules to condense. And so my rule is that if they have the log of the same base, then their results must be equal to each other. And so that's what I'm going to do, is I'm going to set these results equal to each other. And what I have is something linear, and so now I'm going to solve. So I'm going to bring the 2a to the right, and I'm going to bring my negative 7 to the left. Again, no rhyme or reason to that, just made that choice. And so what I get is 2 equals a negative 2a, and then I have to divide by negative 2. So my value for a that would make this true is if a is negative 1. Now again, I need to always be sure that whatever value I figured or came up with for a makes both of my functions positive. So I need to check, is negative 2, right, times negative 1 plus 9 greater than 0? And that's true because this is a positive 2, so the value of 11 is greater than 0, which means that so far this answer works for the left side in terms of not invalidating my restriction. And 7 minus 4 times negative 1, I need to check if that's greater than 0. And that's true again also because 7 plus 4 is 11, and that's positive. And so the value does make both of these functions true, and it also makes them the exact same value. So then this is my final answer, and I don't have any additional work to do. So you can see your strategy of setting the two logarithms with the same base equal to each other and solving is very similar to when we did this with exponential functions. All right, so let's do another one. All right, so again, it doesn't matter what the base looks like. I could write log base of, I don't know, a triangle with the result of a negative 11x plus 2. And that's going to be equal to another log base triangle of x squared plus 30. So again, log base triangle on both, which means I'm going to set these two functions equal to each other. And now what we have is we have a quadratic. So again, you are going to need to review back your previous notes. You want to bring everything to the right-hand side, which means my negative 11x is going to become positive when I move it to the right. And I'm going to be subtracting off 2, which makes this a plus 28. And so I'm looking to create two binomials, right, where there is a product of 28, but a sum of 11. Right? And so then the values I'm going to use are going to be a positive 3 and a positive 8. No, positive 4 and positive 7. All right, so positive 4 and positive 7. All right, so again, just double check that 4 times 7 multiplies to be 28 and adds up to be 11. And now I'm going to use my zero product property. Either x plus 4 is equal to 0 or x plus 7 is 0. So I have two possible answers. And I don't know, I'm not going to box those yet. I need to check them both. And I need to check them both in both of these equations. So I need to make sure that they're both going to work. All right. So if I use x equals negative 4, I need to make sure that this value right here is positive and that the other one is also positive. Right? And this is true. All right? This is going to be 44 plus 2, and so this is all positive. And negative negative is a positive, so this is all positive. So this number, negative 4, is an answer. It's a solution. So then I also need to check what happens if I use negative 7. All right. Again, you want to make sure that you double check because not all of your values are going to work when you do the solving. Right. But again, when I look at this, 77 plus 2 is greater than 0, and also 49 plus 30 is greater than 0, so this one also works, which means I don't have to throw away any of my answers. Both of them are valid. Right. So now, what happens if we have more than one logarithm and I need to be able to use my rules to condense first? All right, and so that's going to be my example number 5. And so I have log base 6 of x plus 1 minus a log base 6 of x equals log base 6 of 29. And so now I'm not allowed to simply just set my functions equal to each other. The only way that works is if I have one logarithm on the left and one on the right. So my goal first is I need to use that rule number 2 to condense. All right, so I need to work just on the left-hand side for a minute and condense down what this looks like. And so because there's a minus sign separating my two logarithms, that means rule number 2, I'm going to make this a quotient. So log base 6 of x plus 1 divided by x is now equal to log base 6 of 29. So now that I've used my rule to condense this to a single logarithm, now I can do the same strategy that I just did in my last two examples. All right. I'm going to focus on setting this side equal to that side. Okay. So I've got x plus 1 equals x must be equal to 29. And so I'm going to fraction bust, all right, which means that I need to get rid of this fraction. And so I'm going to multiply both sides by x. And when I do that, they cancel out. So I'm left with just the numerator is equal to 29x. And again, when I subtract the x from both sides, I'm going to get 1 equals 28x. And then I can divide both sides by 28. So the x value that I think is going to make these true is if I use the fraction 1 over 28. Right. And again, you always want to check that. And I need to make sure that when I take 1 over 28 and add 1, that is going to be greater than 0. And it is. They're both positives. So the sum of two positives is already positive. And if I look at my other function here and plug it in, that's also true. All right, so since it works for all of the functions where I have a variable, then that is my final answer.